Hi guys, we're in my kitchen now, and I kind of wanted to go over with you radiation, convection, and conduction with you, and I'm going to try to assimilate here with a pot of water in my kitchen and how it works with the sun and the earth. So, and all the systems like the wind, currents that blow across the earth as well. So as you can see, my stove is on. I have the glowing ring. So this is radiation. So this would be the sun's electromagnetic waves coming from the source, the sun, through the different layers of the atmosphere. Some make it through, some don't. Most of them don't. All the way to the earth. So I wish I could just pick up my stove and put it up in the air and you could see it's radiating. I can feel that heat. I can't see it. Nope. I got the ring to prove it's on, so I don't want to touch it. I can definitely feel that heat, and it's rising. It doesn't, the higher I put my hands at, the cooler it gets. And what's happening right now is the air doesn't really warm up easily. So right now it's very hot right here. This hot air is rising. It's going to go ahead, and as it pushes the cold air aside, the cold air is going to sink. It's going to move in like a sweeping in where the hot air was, and it's going to kind of create a current like this of movement. I can't feel it. I certainly can't see it. Woo, but I can feel it right now, the heat, and that is radiation. The sun radiates heat to the earth's surface. So now I have a pot of water. It's hot. It's going to make some sizzling noises. There it goes. Okay. So if you will, now we've got radiation. That's the heat from the stove. Now we're going to talk about conduction with a D. Conduction means direct contact. So right now, I just have water in my pot. The pot of water is going to get hot because the pot's going to get hot. The pot's going to get hot from the radiation of this stove. And it's because of that direct contact. If I put my pot of water way up here, it's going to get warm, but it's going to take a long time. It needs that direct contact to really heat up. Think about when you... Never mind. I don't want to confuse me. Okay. Or you. Conduction. It's got to have that direct heat, that direct contact. Now let's talk about convection. So this is where convection gets tricky, because you have to remember that liquid and a gas are fluid, meaning that they move for the space that they are in. If I tip over my pot of water, that water is not going to stay all, put together like the pot size. It's going to go spilling all over the place. A gas, as the water turns into a gas, that gas doesn't stay all right here. It's fluid. It starts to move throughout the room, mainly up and then out. So you need to remember that for convection, you're talking about a gas and a liquid because they are fluid. They adjust to the space that they are in. Okay, so convection. So convection is it's happening inside my pot. It's not, it's a result of the conduction between the radiating stove and it being in the pot and the pot getting warm. But let's see here, it's starting to boil. This is perfect. Okay, so you've got the boiling inside. If we were to be a molecule and jump into this pot of boiling water and look around, this is what we would see. The warmest water in this pot is at the bottom. It's what's closest to the bottom of the pot, which is convecting heat from the radiating stove. The hottest water is at the bottom. The coolest water is at the top. And what's happening as it becomes a vapor, the water molecules start moving really fast at the bottom. Its thermal energy is increasing, the amount that the molecules are moving. They are rising. As the warm molecules are rising and they become a gas, it makes room for the colder molecules to sink and take their place, and kind of creates a cycle looking like this inside of our pot. And that's how that heat is transferred. It's transferred because the gas and the liquid are are blending, they're mixing, they are taking each other's places, they're fluid. They're taking up the room that was left behind when the liquid became a gas. So now we've got this gas. So let's talk a little bit about how this relates to Earth. So we know that the radiating stove is like the sun. It comes down, it warms, some of the rays make it through the atmosphere, most of them don't, but the ones that do hit Earth warm up our oceans and our land. That's the radiation. Then we have conduction. So conduction on Earth is going to be when the heat transfer changes from like walking on hot sand. So by having direct contact with that that sand that's been heated up by the sun's energy, we have caused a conduction with that our foot kind of burning when you walk on hot sand. Convection, that fluid of gases and liquid, that's what's happening right now. You can see it happening. That's kind of our water cycle happening, and that's what's generally happening in our atmosphere. Remember we talked about the greenhouse effect? So if I were to kind of put a tent over this, or let's see here, if I took this bowl and put it over, it's going to trap that steam, that water vapor. It's starting to condense, okay? If we leave it on here for a really long time, it might even form droplets, just like a cloud, part of our water cycle, and it would drip back down onto my stove. So our greenhouse effect, all these different radiations, all this heat that our Earth produces and absorbs and reflects back in the atmosphere, some of them stay trapped, some of them escape back into the atmosphere, just like what's happening now. And our Earth and our atmosphere is so amazing that it keeps just the right amount of energy and heat closest to us to keep us at a good temperature, with allowing enough out of our atmosphere to keep that delicate balance. I'm trying to think, is there anything else I should tell you? I think that's it. So, just a reminder, the sun is radiating heat. Radiating heat, that's radiation. Right now, my stove, that's radiation right there. Conduction is that direct contact. The pot's going to warm up because it's having direct contact with that radiating heat. If we think about Earth, when sand and the water heats up, hot water, hot sand, and your body touches it, and you're like, ooh, that's hot. That's conduction. It's that direct contact. And finally, convection. Convection, again, we're talking about fluid. We're talking about how gas and water kind of just moves freely depending on what kind of environment it's in. And as the Earth absorbs different heat, and as we reflect different heat, that heat kind of gets trapped by our atmosphere, kind of keeping us the right amount of heat inside of closest to our planet, while allowing some of it still to escape back into the atmosphere. So we call that Earth's budget of energy budget, to keep us at a perfect temperature. I think that's it. All right, guys. Bye.